Ça, c'est pour moi.
And we need someone to take notes. If someone can raise their hands. And not look. The notes you can take the notes in whichever language you like.
Actually, I would do it at the table.
Oh yeah, there's no table here.
I can't balance the laptop.
Yeah.
For 2 hours.
Hi.
I have to leave early, so.
You're not taking notes, I know.
Well, also, it's not like if I walk out of the room, it's not because I'm upset.
Yeah, I also get to be in 2 places at the same time.
Well, there's a
TNRG.
Yeah, there's a conflict with something else. We were discussing that. There's too many conflicts.
Entre autres, il me donne juste la main pour les 2 derniers transferts. Je fais un petit update sur les drafts.
Ok.
Voilà. Après, je continue sur.
Bah, je veux dire, tu peux tout faire, hein.
Non, il est trop fort.
Moi, je peux complètement te laisser faire. Ok, bah, tu peux te circuler. Je vais donner à volontaire bientôt pour les notes. De quoi? Pendant que tu vas présenter, je les prendrai pendant que tu présentes.
Merci beaucoup.
Music IETF, in case you wants to.
De quoi?
IETF,
Moi, j'utilise jamais ça.
in case someone wants to jump in and help me.
Je vais faire quoi, je mets dessus. Bon, quand je serai temps de faire une minute, je vais juste les prendre avec le texte. Nico, pendant que moi je ne le vois pas sur mon iPad, quand tu vas présenter, je vais prendre les notes et je te enverrai par email.
Ouais, super.
Cédric, il vient pas? Oh non, il est là. Okay, I think we're going to start since some people need to leave and it's Friday. So thank you for showing up. Again, this is the Coding for Efficient Network Communication Research Group, where we do all kinds of fun things to recover lost packets. So again, tu me mets sur le sous-script? Okay. So a goal obviously is to foster research in network and application layer coding and to improve network performance. And so what we are doing, for those of you who historically were not with us, we started very much by looking at codes and coding libraries because there was some development that was interesting. But we've really fast moved into protocols to facilitate the use of coding and also more and more moving into real-world applications and work in progress. And we know that there's currently work that may be done in the IETF related to this, and obviously the expertise of this group is going to be very important. So this is the usual note well. I know that there's going to be another approach to coding later in the presentation. And I hope the people, Michael and company, that you have really looked at Note well, because I know you work for a company. So if there's any IPR related to your presentation, please mention it. We really have moved. I think this group has done it much better than my other group. We have moved very much into the GitHub to maintain the list of papers and drafts and related material. Obviously, the charter is the data tracker like everybody else. We have a mailing list that you probably all subscribe to. Our slides are going to be on the GitHub and on the data tracker, and we're going to have Meetecho. And actually, when we did you forgot to put that, when we did the hackathon, there was also a Slack channel, which was interesting for the people who were part of the hackathon to be able to collaborate. So this is the agenda. We have, in fact, 6 presentations. I think the hackathon feedback is going to be pretty fast. Then we have an update on network coding and satellite. Then updates on what we are doing for coding for Quick. And there's actually 3 presentations on that. There's the approach that we're doing, which we do within Quick. And you're going to see that there's a presentation that does it as some kind of a Quick tunnel, or actually a coding tunnel for Quick. And then I'm going to do a small presentation on what's going on with the other groups that are related to this. Actually, at the chair's dinner on Wednesday, we all recognize that there should be more collaborations between the different groups, because a lot of time what we're doing is closely related. Vas-y.
Yes. Just a few words about related internet drafts, those in the group. We will talk about a few of them today morning, so I did not mention them in the lists. But otherwise, there was no update for the network coding for CCN and DN requirements and changes in internet drafts. So we discussed with the authors, and they explained that they didn't have time to do that for this IETF meeting. So their position, and they agreed to have it ready for before next IETF. So the idea is to send this updated document to both our group and ICNRG to get a feeling of both groups. And if this feeling is positive, then we may enter the research group LASCO. This is what we decided last time. So it's still valid. Yes, Dave.
So just by way of advertising, the base protocol specs for CCN have been published as RFCs, experimental RFCs. So we have a concrete, pretty stable base to do the binding of any protocol machinery for the network coding to refer to. So something we might want to tell them is when they change their references to the RFC version. Thanks.
Okay, thank you. There was a slight update on the RNC-based symbol representation document. Not much difference, but the authors did not believe it was meaningful to have a new presentation today. There was a much bigger update for the BATS coding scheme for multi-op data transport documents, and I hope we will be able to discuss about this at next IETF in Singapore. And finally, the good news also is not work being done in this group, but closely related. The 3 documents that I pushed forward in the TSVWG working group are about fake frame extension for sliding window codes, and the second one on RLC sliding window codes, and the third one on TDMT32 PRNG for being used in RLC and perhaps somewhere else protocols. All those 3 documents have been accepted, agreed by SG, and now they are in the RFC editor queue. So that's the good news. So for next time, we can say today that there will be a hackathon at next IETF. There will also be a new meeting at next IETF in Singapore. So just to tell you so that you can make arrangements. So that's all for the chair slides.
So next is Nico.
No, it's me.
Is it you?
So next presentation is a quick update on the hackathon, what we did at the hackathon this time. So this is the Swift codec hackathon. Just to remind you, the goals of this hackathon is to design a reference open source and free codec for sliding window codes. This is the third time we meet. We did the work, we organized the work in such a way to be able to, in the first step, produce something that is somewhat compatible with what we did in the RLC draft. So just end-to-end encoding and decoding, nothing in the middle. That's the first step. And the second step would be to further improve this codec so as to be able to do re-encoding within the network if there is a desire for doing this. The goal, of course, is to facilitate testings, benchmarkings, and also adoption. Another goal is to challenge our generic API internet draft that specifies how to interact with such a codec or something else that would be compatible in terms of API. So this time the team was a bit smaller than it used to be in the past. We were 3 people. Cedric, who was there for the 2 days, Saturday and Sunday, but was obliged to work also in a different project. So he was sharing his time between those 2 projects. François Michel was there on Saturday remotely, but he contributed actively. And as far as I'm concerned, I was supposed to be there both on Saturday and Sunday. Unfortunately, I had some problems and I was only able to attend the Sunday. So that's all of this to say that, okay, we didn't make as much progress as we anticipated, as we would have desired, but okay, it's life. We also had some contributions from Umeima, who, since the previous IETF meeting, managed to further update some parts of the codec, and she will continue on doing that. So, anyway, we achieved to do a few things. First of all, we changed the license. That's something important. Just to make it clear, we moved to something which is compatible with the IETF requirements in terms of documents and code inside documents. So this is a simplified BSD license. The encoding part is more or less, well, the main part of the encoder is done. We still have to include a few additional work, a few additional methods for clearing a few things. Anyway, but most of it is done. The decoder is in progress. That's the most complicated part. This is where we have to manage and solve linear systems and do all this complex mathematical machinery. We managed to more or less finalize the demo application. So it's not working for the moment because we don't do decoding, but it's in good shape. It's almost done. And the Python wrapper and test demo in Python, this is also something where we made much progress. We fixed one thing in the generic API internet draft. Mistake in the way we specified the pointer. It was a pointer. It should have been a double pointer, something like that. And then we still have a few open points that we didn't manage to clarify. We'll still need to think about it again. So the next step in in the next IETF hackathon will be to to have something that's working, that managed to do encoding and decoding and interpret. I think it may be feasible if we manage to do some work in between. And then we will continue, as I said, with RLNC, so being able to do re-encoding within the network. So that's the goal. I don't know if there is any comment, question. No, it's okay. Karsten.
Carsten Moment, how would you characterize the performance of what you are doing? Is this high performance implementation, or is this just a proof of concept implementation?
The goal is to have a proof of concept, which is functional, and all those performance optimization stuff that should be done will be left for volunteers who won't have an interest in doing so.
So
But the goal of this hackathon, this demo, is really to have a functional codec.
make it right before you make it fast. I agree with that. So what level of performance improvement do you envision? Will we get this a factor 10 faster or a factor 2 faster?
I think there will be a potential for performance improvement at the end, significant performance improvement. From what I saw in the mathematical operations, then there are a few things that could be done. But whoever wants to contribute on this particular point is welcome, of course, to do that. There are also some conflict of interest for some of us, myself included. I have a proprietary implementation of this, so there are limits to what I can do in this context. Right. But we will have something functional for sure. And since it is open source, BSD, OpenBSD, or BSD license, anybody can further improve it. It's totally free, and I'm pretty sure that people will do that. Okay? Hi. Sorry, Florent.
Oh, c'est ça. Non, ils sont en haut. Si tu vas en haut.
Sorry for this.
C'est les tabs.
Small program. Yeah. Non, j'ai plus. I made a mistake.
Mais je les ai déjà notés.
Je l'ai perdu celui-là.
Ah, t'as perdu celui-là. Okay.
Merci.
Okay. Hello, everyone. This is an update on the draft on network coding for satellite systems. We were in working group last call process since the last IETF, and we had lots of comments from John and Lloyd and yourself. I forgot you on the slides. Sorry for that. So I should have put it and many others. Well, basically, since there were some very deep changes in all the wording and lots of different aspects on the draft, rather than just presenting a diff as we did a lot recently for this draft, I prefer to present it all again. And also for some of the use cases where we say network coding is of interest, we have included some experimental results. So I will go through the document, and first starting with the abstract, where we insist on the fact that we follow and we base everything on the taxonomy document. So coding in the document is a linear combination of packets and operates above the network layer. And it's true that for that, previous versions of the draft was not always very clear. And so there were lots of small issues in wordings. So I think for that, the reviews and the comments we received were very helpful in improving the document. So we have, the objective is to detail what is a multi-gateway satellite systems to identify cases where adding coding is relevant. So we have residual losses end-to-end. We have some multicast services that we want to make reliable and many other use cases, which I will go through now. And the main objective then is to contribute to larger deployment of coding techniques in SATCOM systems, or for SATCOM systems. May not have to be specific, but at least deployed. And we try to identify some open research issues at the end of the document. So if we go more into the details on what the taxonomy document says, is that we do not consider physical layer coding. All that is physical layer related is out of the scope of this document. We have FEC that operates above the network layer, and we only have a linear combination of packets. We don't do any application level coding, such as it could be the case to compress a video flow, for example. And we see that this activity has been very widely discussed in the research community, and so we think the document helps in identifying where using coding is relevant.
Just a quick clarification question. Do you actually mean above the network layer or in or above the network layer?
In or above.
Ah.
I mean, we don't.
Oh, that's fine. Because if you
it's-
say above, you can't do recoding in a router.
Okay,
Right.
what we should say is we do not do layer 2 coding because
Okay,
we do.
so that's not what the slide says. Just,
Yeah, but you're
I hope
right.
that's not what the document says. So clarification.
It is what the document says, so thank you for that, and we will have to make an update. No, I will look at the note later, or not to forget. But thank you. So this is a description of what you can find into the generic satellite system today, following the DVB-S2 standard. So when I say above the network layer, is that we don't play with these BB frames and specific DVB-S2 layer standards, because this is very out of the scope of the IETF and what. So this is, I think, more to introduce some of the wording that I use in the rest of the documents afterwards. For the first use case, I will now go through the different use cases, and for some of them, these are not high-level description use cases. This one is a use case where basically we have two satellite terminals communicating to each other. So there's a coding server. So on the return link, we have satellite terminal A who sends A, satellite terminal B who sends B, and basically the coding server sends A and B on the forward link. So that is a huge capacity optimization. We have introduced this use case not really because there are lots of industrial and application use cases that are relevant, but it's something that we can do and has been demonstrated using real satellites in ASMS 2010. So we should, at least that's why we mention it. There's this reliable multicast when we have a multicast M flow going to different users, satellite terminal A and B. But we have packet losses, so A and B can send to the multicast server the packets that are not received, and M flow can induce coded packets to recover what has been lost. We agree that this could be done by lots of other multicast or broadcast systems, such as Norm or Flute. But they do not use, they're limited to block coding, and they do not actually support sliding window schemes. So that is why we mentioned that in the document. Another use case is hybrid access. Is when you have, and that is very typical in many satcom applications, when you have, for example, users in a boat or in an oil platform or whatever. There's not only the satellite. Satellite is one of the many links that are available. So we can have a CPE on the end user side and a concentrator in the operator network. So we have lots of MPTCP, for example, could go through these networks. And sometimes there are packet losses on one of these links, and inducing coding techniques could be introduced both at the CPE or the concentrator to cover and cope from packet losses. So this opened lots of research questions on how do you impact on MPTCP congestion control, for example. So that's why we mentioned that in this document. This use case concerns us a lot, more than the others, I think. That in this figure you have basically a web application server, our SATCOM system, a multi-gateway system. So if you look at an operator like Eutelsat ground segment, this is what it could look like. So we have tens of gateways in Europe, for example, and then you have a satellite. So you use a DVB-S2 standards to send the data from a gateway to a satellite terminal, and you use the DVB-RCS2 standards for the return link. So we have, apart from some regions, where we have rain fades and packet losses, we can consider in general that this is an error-free link, and we have a high RTT. But the problem is most of the users today are connecting through the satellite box with Wi-Fi link. So in this case, we don't have only an IETF network, but we also have an IETF with losses network. And in this case, I think that if people working on quick and fake are looking for use cases, if they can make it work in this use case, that would help us a lot. So if you want sizing, numbers, or use cases, that would be very relevant for you to experiment and for us to have the results. Because this is, we have not experimented network coding in this solution, but we have a satellite at home. We have a gateway, we have a satellite terminal. So this is a real experiment using a real satellite flying above. And basically we have an HTTP2 transfer of 2 megabytes file from the two endpoints. And here we have 1% losses. I will not go deep into the details, but because I have other results, I can show you if you're interested and can have a chat. But basically, if we look at the page loading time, without these losses, there's no congestion. There's only 1-2 megabytes file transfer. Basically, we compare this CDF without and with losses, and what we can see is that when you have 1% losses, for the median page loading time, we have more than 5 seconds increase. And for the 80% of the cases, we have 18 seconds increase. And so we go from 11 to 30 seconds. So that's very bad quality of experience. So we are trying to find ways of doing something about that. FEC is a solution, maybe. So if you want to help us, that may be an interesting research use case. We have platforms if you want to experiment. So contact me if you want to experiment your solutions in this use case. Another use case we have in satellite is that I told you that in this use case we have no losses, but there are cases where we have losses on satellite link. And we think that in these cases, the physical layer is very constrained. So providing higher layers redundancy can help in releasing the constraints on the physical layer. Sorry for mentioning the physical layer here, and this is more something that I'm not really perfectly familiar with, but what I can tell you is that we have basically the losses pattern you have when you are an antenna on a train. So we can see that we have very low SNR headers of the DVB-S2X standard. So you have here the signal to noise ratios and the modulations that are used, and in this context, we have residual losses. And the peaks we see here are basically the poles along the railway. So basically, you have repeated losses. In another case we have been looking at, we have an LMS, so basically a mobile user. So user is moving, so there's trees, there are lots of issues. So we have this kind of patterns. These traces are available. I'll send them to the list if you want to play with that. We can easily play them in open source tools we have. So if you want to put that in your experiments, that would be great. We have been another use case that is very trendy in the SATCOM industry at the moment is using optical links. But the problem with optical links that we have at the moment is that sometimes they are clouds, and so we have very short fading events. I don't understand everything in this figure, but I put it here and the reference to explain that basically we have lots of people working on it, and we want to explain them that there's not much need in improving a lot of physical layer. Let higher layers deal with improving the quality of experience and dealing with these losses. So we expect to do some measurements in this use case in the next coming months, but we have done some results with the previous traces I had shown earlier. So that's the train, that's the mobile user. So this is an open source tool we have, and we support. So if you want to use it, it's here. Everything is on the wiki. Everything is available. So we have a gateway, a SATCOM, satellite terminal between the SAT and the satellite terminal. We induce these losses, and we have on top of that an erasure coded shadow with a sliding window FEC with the K of 4 and Z of 20. I think the room is familiar with these kind of schemes. If you want more details, we can have a chat. But basically, what I show here is the residual losses. So on the train case, because the pattern is very regular, we can actually find a parameterization and a value of K that solves all the problem. But at some point, K is too high, and basically we have residual losses. So there's, and in the other case, the pattern is so strange that we can't actually do anything with the basic scheme as I presented. So I think that this is very open research issue that may be of interest for the persons in this group. We also are trying to see how this impact on TCP first, and then when we have MPEG dash traffic, because that is the use case that we are interested in. And we think that is very, at least funny to look at, because when you have all these multiple layers that play to each other, strange things happen. So it's at least interesting use case. And so, how much time do I have left? Okay, or okay. So another, but I will go.
Stuttgart question: what are the C's? What are the little C labels? The picture you just had. No, the picture you just put up.
Ah, here.
The C's. C.
I think that, yeah, if I am might be missing in the legend here, is where we could add network coding. Because a network function block is basically we have IP packets coming in and IP packets coming out. So we can, that is where we have all these PEPs and lots of firewalls and all these things you could expect. And access gateways, as they have IP packets coming in, they could also do some things on it. And so one of the trend at the moment is to try to, so basically that is a use case where we have lots of gateway handovers for lots of various reasons. We may want to move the traffic from one gateway to another. And in this case, we may have losses. So that may be a use case of interest for network coding. And now for the research challenge part. So we know that we have proprietary solutions to host coding techniques. In terms of deployment, we know that it is possible, but then we have a problem on the interactions that is something that has been discussed a lot in the group, and is that basically what we are doing at the moment is looking at the fact that when you are adding redundancy, you basically induce lots of jitter on the end-to-end, and we don't know if rack timers actually work well in this context. So if you forget all the duplexing in TCP and only rely on rack, we have in our case, we have retransmission that a lower layer that may happen, and that would have an impact on the, depending on the size of the buffer of your reordering window in your network coding scheme, you may have an impact on how rack tolerates this other reordering. Out of order packets. Another important thing is it is a good thing to have reliability and to have more redundancy, but the problem is that capacity is expensive in the satellite. So there's a trade-off in how much redundancy you had and how much you can improve the quality of experience, but how much does it cost in capacity? Because that's a big open question we have. And then that is more related to another working group that is all the virtualization thing. It's more because we have lots of CPE and gateways and data centers. Now we are moving toward this in satellite. So basically we can host easily these coding techniques end-to-end and between at least two endpoints. So it's more, how do we integrate this solution in a virtualized environment? That is something that is maybe not a research challenge, but at least something to look at deeply, because when you go deep into the details, that's where issues might come up. And then interactions with DTN, because that is something that came out in the discussions. So basically, how do network coding interact with the DTN stack at the moment? We have two open issues on the GitHub because we are very happy to use GitHub. So if you have any comments on the document, we are happy to welcome emails, but issues on the GitHub is way better because it's very easier way for us to explain to you how we assess your comments. So we had a comment on virtualization and the research challenges. Well, basically, we propose to close it. Because the question was, because we are pointing our comments was that there were no idea on what the section means. So do we want to virtualize antennas or virtualize reflector? So that is not what we want to do, but so we try to make it clearer in the text. And then another comment was on DTN and all the CCSDS stuff. We don't want to mess with CCSDS. That's another standard that has its specific use case in satellite industry, and we don't want to consider that. And so we explain in this document that we are just using DVB as an example of what a satellite system is, and not as a base line. And we don't have a specific focus on geo, even if, well, a little bit. So we propose to close this issue as well.
Yes, just one comment. You already sent an email to the list mentioning those two open issues. If I remember correctly, we received no feedback on it. So I suggest you just reply to this and say explicitly what you've said now.
Okay.
We propose to close unless there is an opposition.
Okay.
But do that on the list and not on the GitHub, because I'm not sure
No.
GitHub is so much
It's just that
follow it. As far as I'm concerned,
Okay. No.
I didn't follow the GitHub comments, etc.
It was easier for us. We just copy pasted what we received by emails in the GitHub
Yeah.
to then change, provide the pull request and everything. It's clearer, but then.
Okay,
We'll
so
do it.
send it to the list, make it clear that you want to close those two comments, open questions, and we'll follow. Thank you. Yes, so what's next step? So we received the comments from Stuart recently, yesterday. Thank you very much. I suggest you answer those comments, do an update, and then I see no reason not to start a new working group, research group. It's not a working group, a research group last call.
Okay. Yeah.
On this updated document. So,
Okay.
other opinion? No, it's okay. Thank you, Nicolas.
Thank you.
Non, c'est bon. So this is a technical presentation of what we have done for this Coding for Quick document. We changed a lot of things, as I will explain. So this is joint work with François, Marie-Jo, and Yann. So just a summary of the situation at previous IETF. There were two proposals for adding FEC within Quick. The one that I mentioned here is the one that was implemented in the previous revision of this document. The idea was to do that within a stream, notion of stream for Quick, with good properties, meaning that some of the streams have more requirements in terms of reliability than others. So it makes sense to protect more those streams than the rest. There was also a good property that it was possible to do that without changing at all the Quick source packet, the original packet. So that's great to do that. But of course, there are consequences, side effects. One of those side effects is the fact that, okay, this is a stream concept. So being a stream concept, there is no there's no boundary, no notion of boundaries, and it's not something that could be easily applicable dedicated to a datagram approach, another way to transport data, transport payload within Quick. So that's not very good from this point of view. There's also another side effect that was a bit annoying. This notion of stream makes it possible for a source symbol to straddle several packets, and that's something that we don't want so much. So the second proposal from François was doing it totally differently. The idea was to protect packets, to consider packets, consider the payload of this packet, and to segment this payload into source symbols so as to do a protection for all those frames within these packets, within those packets. So it's another way to do that. It preserves packet boundaries. That's a good point. When you recover something, you know that it fits inside a given quick packet. You also have this good property that source symbols never straddle several quick packets. So that's also something nice. With some additional side effects that, okay, we need to change a little bit the original quick packets, but something that can accommodate. And it's also a bit more difficult to try to protect a subset of a packet. So those are things that we will elaborate a little bit more in this presentation. So I don't want to enter too much into details at the moment. So we had discussions together, and we decided to change totally the way we propose to do FEC in Quick, and to follow what more or less what François was proposing, namely doing that inside packet, across packet frames. So that's what is now implemented in this 03 revision of this document. We added a few additional features, as I will explain. So many things are still the same. Several key architectural concepts remain. One of them being that we apply FEC encoding and decoding before doing encryption, which means that middle boxes will not be able to do anything from this data flow. It will be an encrypted data flow, no way to distinguish between source and repair packets. There's no way to do that. That's the first aspect. Another aspect is that, as before, we try to provide a generic feature, which is compatible more or less with any effect scheme that we may want to use within Quick. And we move all the effect scheme specific considerations, how to do that with such or such code, for instance, within a separate dedicated internet drafts. So that's the case with this existing RLC for Quick internet drafts. The third point that we kept is that we absolutely want to be congestion control compatible. We do not want to interfere with the way congestion control may happen within Quick. So we use dedicated recovered frames to inform the sender that some packet has been lost, but has been recovered by FEC decoding at the receiver. So that the sender can take it into account, do whatever he needs to do from a congestion control point of view, no change from this point of view, and of course avoid retransmitting this packet that has been recovered. So that's something which I think is also important for acceptance of FEC in Quick. Yes.
Dave, tell me to go away if you're going to cover this in a minute. So two questions came up when you put this down. Number one is, do you have a sense as to whether this scheme is more friendly to multipath than the old scheme? My intuition says it is more friendly to multipath, but I'm not sure.
Yes, maybe, because there is this, source symbol does not straddle several packets, quick packets, and if you send one on one side and the other one on the other side, maybe it will reduce the probability of having packet loss, source symbol losses. Yeah.
Especially if multipath is done not on a stream basis itself, but on a packet basis. The second thing is this recovered frame thing is very nice. Have you thought about whether this also could be used to change the level of coding? So that if you get recovered frames and there's very few of them, based on your current coding, you might want to reduce the coding or increase it if the recovered frames start showing a lot of recovered frames?
Yes, maybe it could be used to piggyback some statistics to the sender. More, it could be done for helping the sender setting the right code rate, the right amount of repair data that he wants to send. Maybe that's something we can.
Thanks.
Yeah, But anyway, the goal was a bit different, but yes, we could take advantage of this for doing additional things. Yeah. Thank you. So the key point in all those in this work is the question: how do we map quick packets to source symbols? That's really the key aspect, and there are several things to consider. First of all, of course, the quick source packet is of variable size, but we absolutely want to keep the symbol size fixed for the whole duration of a quick connection, because it makes things much simpler to manage within the encoder and decoder if we have this fixed size property. So now the question that arises is what is the appropriate size for those source symbols? Should we keep, so the E parameter, the big E parameter is this source symbol size. So should we keep a small source symbol size? Should we use a larger symbol size? Of course, if we use larger symbol size, there will be perhaps the opportunity to fit all the quick packet payload within a single source symbol, so that makes things easier to manage. But at the same time, if we have variable size, largely variable size source packets, a lot of small source packets, and from time to time bigger source packets, then it's a waste. It will generate more overhead, transmission overhead, so there is a waste of efficiency from this point of view. So we need to find a balance. There are several aspects to take into account to find an appropriate balance. There is no single magic value for this symbol size. It really depends on the use case, so we need to have a better understanding of what type of data will be carried within this quick connection, most probably. So that's something that will not be fixed inside this document in the generic framework. That's something that remains to be adjusted based on the use case, based on deployment considerations. So it will be but we have this flexibility to manage at the same time small or larger size, symbol size in this document. That's what is most important. So let me explain how we do this quick packet to source symbol mapping. So there are two steps. The first step is the one that is now on this slide. It consists in segmented quick packet payload, in fact, into chunks. So the way we do that is the following. First of all, we add padding to packet payload in order to be a multiple of E-1 plus this E-5 initial chunk. So we need to have this to have a multiple number of chunks. Well, no, sorry, the padded length must be a multiple of E-1 and E-5. Why there is a difference between E-5 and E-1 will be explained later on. The way we do that is by prepending padding frames to the payload. So this the quick protocol has this nice feature that we can add padding, and 1 0 byte padding is itself a padding frame. So this is a reserve value. So by putting this padding at the beginning rather than the end of the packet payload, it makes it possible for a decoder to skip all those padding frames, even if the size of the frame is not specified, of the other frames is not specified, which is something which may happen. So this is a bit complex, but by doing that at the beginning of the payload instead of at the end of the payload, removes this requirement to have an additional signaling field that will tell you how long it is, how long the payload is, so that for the receiver to skip the final padding if we are doing that this way. So it's something that is quite efficient. So we do that padding, and we segment this padded packet payload into chunks. So in this example, we have 3 quick packets, and as you can see, there are 4 chunks for the first one, 3 for the second and third ones. So that's the first step. We have chunks now. So what do we do with chunks? Now we need to do a mapping between chunks and source symbols. And the way we do that is by prepending 1 byte of metadata. I will explain you what is inside this 1 byte metadata. And then for the first chunk, we have this additional packet number, which is a quick packet number, which is protected explicitly in the first source symbol of a quick packet. So the association of this metadata plus packet number plus packet chunk is constitute this source symbol. So that's for the first chunk of a quick packet, and the remaining chunks of source packets only have this metadata. There is no need to repeat the packet number that will be anyway protected by the previous source symbol. So in that case, the source symbol is this metadata, 1 byte metadata plus packet chunk. And all of this constitutes this source symbol. So that's the way it works. So now what do we put inside this metadata byte? Well, it's pretty simple. There are 3 bytes, there are 3 bits that are used. The first one is just to indicate the N field is just to indicate that there is a packet number that will follow, a 4 bytes packet number. The S and E bits are there to signal that, okay, this is the first chunk of a quick packet for the S start bit, or the last chunk of a quick packet for the E bits. And with this, we can inform the decoder, we can inform the receiver after decoding that, okay, that's the first chunk, that's the last chunk, those chunks are in the middle. Or maybe if there is a single chunk for a given packet payload, that's the only chunk because there will be at the same time the first and last bits that will be set. So that's an easy way to do that. And as I said, there is this packet number. This is also important to have this quick packet number inside some of the chunks, because sorry, not the chunks, but the source symbols, because it's something important for a decoder to indicate what packet has been recovered by the FEC decoding process. I remember that there is this recovered frame that will go to the sender to indicate to the sender that this frame has this quick packet has been decoded, has been lost but decoded. So we need to indicate to the receiver which packet it is. And since the quick header is not protected by FEC itself, we need to carry this information in some other way, and we do that by including this quick packet number inside the first source symbol of a quick packet. So that's a trick to inform the decoder, to inform the sender that this packet and not another one has been recovered. So that's why it's important. So the big picture now, if I sum up, we have this quick packet. We do padding, initial padding. We split the content of this, the packet payload plus padding into chunks. In this example, we have 4 chunks. And then we create with this additional metadata, and potentially for the first chunk, for the first symbol, the packet number, we create those source symbols. And this way it's working. It's working. I just want to convince you that it's working. That's an example. So let's imagine that in orange we received or we decoded, or maybe something is missing, several source symbols at the beginning, and the same for the last part. And in the middle, at some point of time, the decoder can decode those 4 source symbols. So by looking at the first byte of each source symbol, it will determine that for the first one, this is the first chunk of the packet. For the last source symbol, it will determine that this is the last one, and those 2 in the middle are just in the middle. So it will determine all of this, and it will be able to construct by removing those additional bytes, M metadata bytes. It will remove that, but it will reconstruct the original quick packet and be able to do what it has to do with this recovered source packet, quick source packets. So it explains why we need to add those additional metadata stuff. Then we change just a little bit the original quick packets with this approach. We need to carry this additional fake source FPI, fake payload information. So that's signaling information that we need to put inside the original quick packets that carries source packets, the source data, original data to the receiver. We need to do that just to tell the receiver tell the decoder, okay, that quick packet carries these those source symbols. We have this source symbol identifier that is typically inside this additional frame. If we are dealing with block codes, maybe we'll also have an indication of an identification of the block it corresponds to. So there are a few things like that that needs to be carried inside quick packets, original quick packets. And concerning the repair frames, we can transmit them in additional quick packets. We can perhaps put several repair frames together inside the same quick packet. It's not a big deal if it is small enough. If E is small enough to be able to do that, it's not a big deal. And those repair frames will be identified as such by a dedicated repair frame identifier. So it's backward compatible. Both of them are backward compatible, but because a receiver that does not know anything about FEC will skip those frames, and that's it. So there are a few open points. One of them being the possibility perhaps to ignore some of the frames in this process, because those frames are not that important from we can avoid protecting them with FEC techniques. That's the case of perhaps acknowledgement frames. And it also be the case for non-real-time, non-delay sensitive streams, maybe. So we may want to do that. I'm not totally sure it's important. In any case, if we want to do that, it means that we need to inform the receiver. We need to keep both encoder and decoder synchronized. So it means additional signaling. And at the moment, we don't really know how to do this additional signaling. So there are open questions here. So this is something that needs to be experimented, implemented. We need to have more background, more information, more thoughts on those techniques if we really want to do that. Otherwise, we protect the full payload of quick packets. It's always possible. There is also this choice of this E symbol size parameter that I've already mentioned. Next things to be done. Well, we need to update the RLC for quick documents. We did not have time to do that presently, so it's still compatible with, it's still referencing the previous version of this framework document. So that's something we need to be done. And of course, we need to experiment. And from this point of view, the Swift codec will be quite useful. That's all. Just after this talk, there is François will discuss about the on-progress implementation, reference implementation for all this. Yes.
Stuttgart again. Be a little bit cautious about not protecting ACKs. I think if you look at the net impact on performance, it may be more substantial than you imagine.
Okay. Yeah. This is something that we discussed quickly with Jan Sweat at previous IETF. There was some belief that it could make sense to avoid protecting them, but well, that's an open point, yes.
So I'm scratching my head about one thing. The presentation seems to be oriented toward systematic codes entirely.
Yes.
So if you
that's the idea.
Are we planning to support non-systematic codes? And if so, what happens? Just all the packets are repair packets?
By default, we have in mind this systematic approach where we send both the source and the repair packets. But if we want to avoid sending source packets, it's not a big deal. It's just a matter of producing more repair packets and sending more repair packets so the receiver can decode the receiver.
Yeah, it's
not a big deal. No.
Yeah, it seems straightforward. I just wanted to check because some of the description basically said, well, you know, I don't need to worry about the repair packets, right? But if it's a non-systematic code, then everything's in a repair packet. Okay.
I was mentioning the possibility.
Intuitively, it seems like everything was okay, but I just wanted to check.
Okay, this is Marie-José. I think the assumption that it is a systematic code. It's because it helps so much of the decoding.
Sure.
So that, I think it's not a bad assumption, but I agree with you. It should be more, it should be generic.
It's just nice if
Yeah.
we check and make sure we haven't done something, like silly that makes non-systematic codes not work when it doesn't, when you could have done something just as easy and they would both work. That's all.
Yeah. Okay. Thank you.
Brandon Williams. I don't get a clear indication of whether you've looked really carefully at how well this approach aligns with the API approach in the other document. Do you see any challenges presented from the?
The API should be able to both are separate documents for different aspects of the same big picture. I don't think there is much dependency on the two, between the two.
What wasn't clear whether anything fell out of sort of the quick specific discussions that might drive any changes around the API.
I don't think so at the moment.
If not, that's awesome. That seems like a validation of the API.
Yes, but the idea is indeed to use this API and Swift codec inside existing C implementations of Quick.
John Border. Quick observation that at least as we presented it, N equals S, so it's redundant. Does a non-systematic code, would that help in this idea was brought up earlier of being able to adapt how much extra coding you're putting in? Because I'm definitely interested in that because of the latency over satellite. That as the error, if I go into rain fade, can I increase the coding on the fly if I can detect I have a higher loss rate, et cetera? I'm assuming it's going to depend somewhat on which code you pick on how easy it is. It's hard to do that.
Clearly, it depends on the nature of the code. With Swift and sliding window code, it's pretty easy to add more repair packets. It's just a matter of computing a new linear combination of what is at the moment inside the sliding coding window and send it. So it's pretty easy. With other codes, there are constraints. It depends. But yes. We have this flexibility to use whatever we want in terms of code inside this quick protocol. So at least this is the way we want to design it. So
we just want to make sure there's some flexibility for what kind of information you can pass back.
Yeah.
Stu again. This looks like it probably constrains us to, if we're doing a hybrid ARQ, to doing type 1. Doesn't look like it would support a type 2, or am I missing something?
Type 1 and type 2, what do you refer to?
Type 2 would be an incremental redundancy hybrid ARQ where additional repair packets are sent in response to a NAC, as opposed to repair packets are, you just pick a priori how many you're going to send and perhaps adapt it based upon the number.
In that case, if I remember and if I understand correctly, those additional repair packets are referring to the ones that have been identified as being lost. No? Try to figuring out what it means.
Well, so there's no actual retransmission, so perhaps ARQ becomes a misnomer in this case. It's just a matter of sending additional repair packets in sufficient numbers to allow for essentially increasing dynamically the error correcting capacity of the code.
Yeah. The only constraint in that case is to manage the sliding window in an appropriate way, because once these all packets have been removed from the sliding window, then there's no way for the encoder to produce repair symbols protecting those packets. So it's more a matter of using correctly those FEC codes, if we are discussing about sliding window codes, than anything else. It's a matter of using it in the right way compared to what are your requirements.
So Dave, somebody made a nice comment and it just sort of flew by, which is the way you've described the encoding, S and N bits are redundant because you can only set the N bit if the S bit is set. And it's invalid to have a packet with the S bit set and not the N bit set. I mean, is there some kind of flexibility there that you meant to describe and didn't?
Yes, the N bit, which means that, okay, there will be this packet number identifier inside the source symbol is something for which I don't have a clear idea at the moment. Is it optional or not? In the slides I mentioned optional. That's something we need to discuss and figure out how to do that exactly. Is it mandatory
the
or
description
optional?
seemed like you were saying that the packet number is always in the first packet, which is signaled with S, and it's an error if some other chunk has N set other than the chunk with S set. Right.
I mentioned, it's optional, but this is something we need to
it's optional. Okay.
Yes, at the moment we have this in mind, but maybe it's a mistake. That's something we need to discuss and evaluate. Is it really all the time? Is it all the time required to have it or not? Optional. That's an open point. I should have mentioned this in the open points. Yes. Yeah. Good. Good comment. Alphabet.
There is one coding choice that you can use for something.
Yeah. No, I didn't catch.
Okay.
But that's an additional point that I should mention in this list. Yes. Sure. We don't claim we have fixed all the problems, especially when we see how many discussions, live discussions, there are in the quick working group.
Does anybody have the blue sheet? Oh, yeah. Thank you.
So here we are in between us, I will say. But once we go to a quick working group, there will be many more comments on specific aspects. So we need to clarify all of them as much as possible. And we'll see after. And clearly the packet number is one of them. Yes. Okay, thank you. So now I will give the floor to Francois, who will talk about his implementation of all of this.
So hello, can you hear me?
Yes.
Yes.
I hear you.
Okay, great. Okay.
Wait. I need to show the slides.
Yeah, that's fine.
Yes, you can start talking.
Wait a little bit. It's not a big deal.
Okay, so basically I will present really briefly the coding for quick current work in progress reference implementation. So next slide. So compared to the previous version, the draft has changed quite a lot. And at the same time, we had an homemade version of an implementation of a fake extension for quick that we made, but that was based on an old version of a quick implementation, and it was also including a multipath extension. So it was quite complicated to maintain and complicated to make evolve. So we decided to propose a new implementation from scratch, and whose goal is to be simple, easy to learn and to play with. And the goal is also to stay up to date with the draft specification and also with the base quick implementation, which is Quick Go. So next slide. So if you want to check the source code, it's available on GitHub. The slides are also on the NWCRG GitHub, so you will be able to get the link there. Currently, the implementation only supports block codes because it's easier and the RLC specification is still evolving. So we currently provide a simple XOR and read Solomon code, and we already use the recovered frame as Vincent explained. And so currently what we are doing is that we are not protecting the ACK frame, so we can discuss about that. Currently, we are stripping them out of the packet payload when we protect the packet payload. The design of the implementation is closely tied to the design of the draft, because, for example, a FX scheme can define its own format for the reaper frame. So if you can, for example, have a block scheme that has a different format for the reaper frame than a convolution FX scheme. It's the same for the record frame. Next slide. So if you want a simple example, let's say that you want to add a new block code, you can simply define a new type in Go, implement 3 different functions, and you should be able to make it work. So, for example, you can decide to implement a block-based RLC currently. And you can also decide to implement convolution of X schemes and stuff, but it's a little bit more complicated. Next slide. So what do we plan to do next? So first, to add a sliding window FX scheme and also wire the code with the Swift codec once it's done. We would like to add a proper test suite. So currently, the QuickGo test suite is still working, but we would like to add new unit tests to test the FEC extension. And so we would also like to move forward in a general way to have a more clever symbol scheduling, because currently it works, but it's not really efficient because we do not do things very cleverly. And we can also try to wire new applications above the implementation, because we chose QuickGo because it's an implementation that provides a rich API, which is easy to use and to play with. So that's something we could also already try to do. Next slide. And so finally, there is a list of other interesting implementations to look at. So there is first RQuick, which will be presented in less than 5 minutes. And finally, we will also present another quick implementation at SIGCOMM 19, which is bundled with a paper, which basically revisits the way on how we can deploy a complex extension such as FEC. So the source code of this implementation will also be publicly available, so you can stay tuned and you can get access to it after SIGCOMM. So next slide. So thank you very much, and feel free to ask your questions if you have.
Someone? Also, just one question. How many implementations do you have now?
Oh, we have the old one, we have this new one, and we have the one for SIGCOMM. So 3, but the old one, I think we will get rid of it.
Okay, your goal is to continue with the QuickGo implementation and to maintain it as the main reference implementation.
Yes, this one and the SIGCOMM one, these two versions.
Okay, SIGCOMM. Okay.
This one and the SIGCOMM, so the QuickGo and the SIGCOMM, both of them.
Okay. No comment, no question. So, no. Okay, so thank you, François.
Thank you.
Keep us in touch, and if you have new results, experimental results for next IETF, you will be welcome, of course.
Okay, thank you.
Okay, so next presentation is for our quick, another quick and FEC approach. So Mirai, can you hear me? Can you go on the mic? We're waiting for you.
Or Josu or somebody, can you click the button so you start talking to us?
Okay, no news. You're on the list. We can see you on Miteco, but without any action from you, we won't be able to give you the floor. So go ask the mic on Miteco. Okay, so we are going to swap the last two presentations. So now Marie-Josée will talk about relationship with other initiatives, and then we will come back to you. Mireille. Okay? I don't know if you can hear me, but let's do that.
Okay. So, like I said at the beginning, there is a strong, I think, need and a strong opinion about starting to link a lot of groups together. And, you know, we're essentially a service for the network, so we obviously have links to other people. And there's other groups who are looking at ways of implementing the coding. So obviously they also have issues, or they actually have related issues. So can I get the clicker? Yes. Thank you. So we've had, it's sad that Dave just left, but we've had a long-running relationship with ICNRG, which dates back to a paper I wrote about 10 years ago. And this led to this idea of network coding for content-centric networking, requirements and challenges. There's the draft that was discussed at the beginning. And it is going to be a joint network coding and ICNRG RFC when it comes to that. And it's being reviewed, as Vincent mentioned, but this has been, I think, one example of a relationship that has worked really well between the two groups. And it was a bit of a win-win because it showed that you could implement network coding inside a information-centric network. So that was very nice. COIN, this is really new. COIN, COIN is my other co-chair group. And we had a hackathon on Saturday where we started looking at things that could be done with P4, which is this language allows you to program low-level switching. And there's actually a group with Salvatore Signorello and his team in Lisbon are actually looking at an implementation of network coding in P4, which was one of the projects that I had on my list, actually, which was fun that they're doing it. And this also is interesting for another reason, that it will prove that the ideas of doing re-encoding in switches inside the network can be done really fast. So that could be interesting results. They were not ready for this IETF. They are going to upload their paper and they want to write a draft on it, and it's going to be a joint COIN network coding draft. So it will be submitted in both groups, and we hope that it's going to be presented in Singapore in both groups. So that's going to be fun and really show the relationship. So this is actually something that I've been involved since Monday, and a few of us have been involved since Monday. There was a non-forming buff on Monday about something called loops, which is some kind of hop-by-hop performance optimization. And with FEC on selected paths, there was a mention of Swift. In the presentation, there was no mention of the other potential codecs, but obviously Swift is the work of Swift is related. There was, you know, we know from the work that we've done here that congestion control will be an issue. You saw from the quick presentation that we now signal that the packet has been recovered so that we don't start messing up with the congestion control. There's been a lot of work in this group on this, and it's going to be important, I think, for the loops if it ever becomes. And yes, you have, Carsten, you have a question.
Yeah, Carsten, I'm one of the proponents of this BOF. This is actually not hop by hop. This is meant to be used on path segments, which of course may be single hops, but in many cases actually are.
Okay, I probably misinterpreted. For me, the hop by hop was path segment. So it's me not writing it right, but I understood it was different segments.
Yeah. So basically the point is that within a path that generally is okay, there may be a challenged subset. and you may want to install something at the ingress and the egress of that challenge subset to fix things. And mainly right now we're looking at retransmission, and FEC is just another option that has been implemented by the people who are building prototypes of this. And the main point is this is don't look, don't touch thing. So we don't care what we transport as long as it is an IP packet.
Okay.
So if it's quick, great. If it's something else, also great.
No, but I mean that the below, the reason I mentioned quick on the slide is that there was a question from John in particular about how quick would work. There was a presentation on quick would work. So that's why I said that there's a quick, the presentation that we just skipped, and that's sad, actually does some kind of a network coding tunnel. And that could be another solution that you guys could look at. So, yeah,
So
I was there.
the don't look, don't touch also includes that we don't talk to the host. So whatever the host does is completely opaque. Of course, the ingress or the egress might actually be the host in the end.
Yeah.
So that's an interesting special case, but the thing's supposed to be really simple and get by without talking to the host.
Yeah, and actually, if you saw the presentation from Nicholas, some of his architectures looked a lot like some of the slides I saw on Monday. So I think the message here is that, you know, there is collaboration. We're all on the same mailing list. And, you know, again, historically, we ended up being a research group because the IETF was not ready 5-6 years ago for a working group that dealt with the type of architectures that we're discussing here. So we ended up being a research group, but in the meantime, a lot of the people involved have actually worked on real-world implementation, and that could be, if your group gets chartered, that could be a way for some of the work that was done here to move into the IETF, because there's people in this room who know that the type of architecture you're discussing with loops, including FEC, is actually running code in a lot of different implementations, maybe more proprietary, maybe a little bit more less known. There's probably ways that some of these things may end up being, you know, in the public domain. So it's just this, I made, you know, and again, you know, I'm talking about collaboration, and this one is not between two research groups, but between a research group and a potential working group.
The idea is that most of us have been working on something for a while. So for me, this would be 20 years ago when we did the first thing of this kind. This is something that can be standardized. But of course, the FEC part is the more interesting part, and there we definitely hope to get very good input from this research group.
Thank you. There's a question, I think, on Miteko.
Depends on Mihai. Is on Miteko.
Oh, Mihai is connected.
For the following, yeah.
Okay. So that's it. Yeah, that's it. We are also looking at links to other groups, but those were the ones that right now were the ones that were the most likely candidates. So if there's no other questions, we'll move to the presentation that was supposed to be before me. Thank you.
Hello?
Hello. Wait, yes, we can hear you. Wait a few seconds. I'm doing your slides.
Yeah, thank you. These are the consequences of submitting my presentation request too late. Sorry.
No problem.
Okay.
Okay, so it's working. So tell me when you want me to change slides.
Okay. Okay, thank you.
You have the floor.
So good part of the day. Good morning to the personal attendees. My name is Mikhail. I'm a PhD student from University of Cantabria and Ikerlan Research Center. We don't have any patents, nothing dangerous here, so And all the participants that are mentioned in this slide are okay with presenting publicly the contents of this presentation. I'm going to present you Robust Quick, or RQuick, which is another implementation of Fact Quick, parallel to the one that was presented in François Michel. Next slide, please. Thank you. So, as I mentioned, we were developing it in parallel, so we followed a different approach with different results, which could be a good review later. Which one is going to be better in which cases, if there will be any difference at all? We will need to see that in the future. You have a link to the GitHub where we have this project. As I will mention later, this work is not over. We will include more features. Next slide, please.
I have a question. This is Marie-José without the chair hat. Your last statement says which quick FEC is better and in which cases, and is it worth merging? I think I have an answer to this. I think we don't know which quick FEC is best because we're still testing these things. And the worth merging, my experience in network coding would say that merging them is probably not a good idea. I think the decision that we made when we started working with Google on the Quick and FEC was that we were going to give operators a choice of the code they were going to use. And in our case, it's inside. And in your case, it could be that they also decide to use your approach. But I don't think both together would work because then you would have a lot of issues with repair packets, which ones are repairs. We are above the encryption, you're below. I don't think there's a way that we could make it work. So I think that's the answer to your last slide. To your last slide.
I think I was referring more to the good practices for different cases. That's all. But thank you. Yes. Okay. Next slide. Okay. According to Coding for Quick documents, quick packets should be encoded before encryption. We didn't consult that document back then, so we encode after encryption for two reasons. The first one is because it seemed more simpler implementation. And the second reason is because this way we can evolve towards quick with network coding in a more easier way.
This is Marie-José again. Question. The fact that you're coding after the encryption, but also puts kind of the encoded packets in the clear. How are you going to deal with the fact that people would know that this is an encoded packet? Actually, if I'm on the line and I'm looking at things going through, I will probably be able to see that it's an encoded packet. How do you plan to deal with the security issues of that?
Well, the security issues are dealt directly by Quick. So that's our idea. There is an encryption applied. And you don't really see the difference. Oh, and even if you see the difference, we need to review that. The short answer is we need to review that. So far, we were trusting that Quick has enough mechanisms to avoid the security issues. Okay, the packets are encrypted, so we were not expecting anything. We need to review that. Here, I'm trying to depict the difficulties of, well, how would Quick with network coding look like before and after encrypting, before and after encoding. So as Vincent already mentioned, if you encode before encryption, it's impossible or very, very hard to recode at intermediate nodes. However, if you encode after encryption, the process is much simpler, apart from being possible. Next slide, please. So some technical details here. We are basing our code on Quick Go project by Lucas Clemente and Martin Simon. We took the code base after the release of version 070. we want to update that. We have implemented only one coding scheme, XOR, with adaptation. After every n coded packet, insert an XOR coded packet. How big or small it can, it depends on the losses that we observe. So far, we have a 4-byte long header, 4 extra bytes for quick packet, but this will surely change in the next future. Next slide, please. This is a graphical overview of our implementation. With red boxes, we have marked the parts that we have added or we have changed in the original quick. So we have added decoder, encoder, the adaptive coding rate algorithm, and we have also changed a little bit the session right now to buffer the packets that will need to be coded. Okay, next slide, please. Our adaptive coding rate observes the number of retransmissions and transmissions. I had some echo with Michel, but with Francois, but he was speaking so clearly that I didn't complain. So adaptive algorithm checks in the last n coded periods of NXT the number of transmissions and retransmissions. And then, based on some parameters that we configure, which we can define as aggressiveness parameters, we decide if we need to increase or decrease the ratio, the coding ratio, and how much. And on the graph, you have a little check that shows that for uniform losses, this algorithm should define a more constant coding rate. One detail, we try to not to go beyond the congestion control window, so we can recover at any moment. Okay. I see that there are complaints about echo. Try to. Hello, do you hear me better now? Is there more or less echo?
It's okay.
It's fine.
Okay, so I'll continue with the headset. But could you hear more or less okay the previous parts? Please somebody answer on the chat. Or we can leave the doubts about the previous part for later for the question. Okay, for the questions. Next slide, please. Okay, we have evaluated our code, both with simulations and physical setup. We check that our quick is not impairing parallel normal quick sessions. And we have considered for simulations 3 cases: wireless network, normal typical Wi-Fi, cellular network, and satellite communications. In physical setup, we had cellular network and Wi-Fi. We had 2 kinds of traffics: bulk transfer and web browsing. As the output that you see, the main output is the completion ratio, that is, the time in which our quick sends the necessary information divided by the time that normal quick would do that. As you can see, in bulk transfer, we have significant improvements in all cases. However, in web browsing, the improvement is not that big. We believe that this is because our adaptive ratio algorithm is not optimized for the slow start phase in the congestion control window. We are working on it. And the summary, which is the next slide. Thank you. So as a summary, we have a different approach to FEC, which is easy to evolve into network coding. The work is, as I said, the work is not over. We are going to implement more features, more coding schemes, random linear coding, Reed-Solomon. We want to update our base code and also include multipass and network coding. So if you have any questions, I went very fast. Surely, I'm sure you will have questions.
Hello, it's Nicolas Kuhn. Can we go to the previous slide, please?
What?
On the satellite axis, you can consider 500 milliseconds RTT, 20 megs downstream, and 5 megabits upstream. That's basically what you have in public SATCOM accesses.
Sorry?
You can change the simulation parameters to 20 megabits downstreams for the satellite link and 500 milliseconds.
Okay, thank you. Thank you.
Hello, Michael Welzer. I was curious about the relationship between what you're doing and congestion control. Maybe, well, can you also go back even one more slide? I think that is the slide that says it, isn't it? So if I understand this correctly, you're not changing the congestion control or like working with the congestion control inside Quick because it's supposed to be transparent to that. So then you're repairing only the losses that don't play a role, or how is that?
This is transparent to congestion control.
Okay, so how do you ensure that you're not hiding losses that affect the congestion control response?
Sorry. Excuse me. How?
I mean, well, if there is a loss, normally congestion control should respond to that, right? So if you repair all losses, then you're ruining congestion control.
Okay, we are delaying the control losses. So if we cannot recover that, we report that loss. So we have one loss. We are waiting for the coded packet. If we start to receive packets from the new generation, we report that loss. If not, we report it as a received packet.
Okay. I'll have to read the details, I guess. If you're probably working on a paper on this.
There's going to be a paper on Globecom.
Okay. Thank you.
Brandon Williams. The specific difference between this mechanism and the other one that sits above the encryption layer that I'm curious whether you have thoughts about is it seems to me that the parameters you want or the desirable characteristics that you want from the network differ distinctly between a bulk data transfer that wants to be reliable and say video streaming that doesn't put as high a priority on reliability. How do you see being able to make the necessary trade-offs there if you're sitting beneath the encryption layer and can't tell the difference between the packets that are associated with reliable and unreliable transport use cases?
Okay, we can actually detect which packets are reliable or not. I mean, which packets have priority or not, observing them in the session module. So this is not this algorithm, this FEC implementation is embedded into Quick, so we can see which packets have priority. I don't know if I've answered.
Do you mean that I didn't get the sense from the talk, and maybe I need to read the document to get a better idea. I didn't get the sense that you were selectively applying the FEC, or that you had the capability to have any kind of differences applied between different streams. Are you selectively applying the?
No. As of right now, we don't differentiate. We just tested our FEC with bulk transfer and web browsing, but so far we are not differentiating.
Do you have a plan to look into that and develop a more clear mechanism for being able to selectively apply FEC at the layer where you're applying it?
We can check into that, but this is not bad for the ghost feature.
Okay, that seems like something that's going to be important for you to look into. That certainly is one of the things that has come up in discussions about applying FEC for quick, that some streams will benefit and some streams won't benefit much, and there's a desire to be selective about it, as well as selective about the parameters that are applied based on the nature of the individual stream.
Okay, I'm taking note. Thank you.
This is Marie-José again. I go back to what Michael was saying. I've done a lot of this coding with congestion control, maybe too much, and I have the impression you really need to look into how you will interact with congestion control, because right now you're correcting all the losses, but the congestion control does not know the nature of the recovery that you're doing, and maybe the thing that were lost were things that should be lost and should not be recovered because there was something that was needed in order to prevent buffer overflows and a ton of things. So you need to really, I think, look at your implementation in terms of how it works, especially in a congested network where the losses will not be due to physical layer, residual errors, but obviously because it was needed to drop the packets to maintain network integrity. And I think what you proposed here, I think it works when there's no congestion, and it's great. But if you get into a more like I would say the architecture that Karsten was mentioning, when you have more than one path segments who have very different characteristics, maybe on your wireless path segment, there is very little congestion and all your losses are due to physical layer residual error. But once you get on the wired part of the network, it may be a very different, something very different happening. And I'm speaking from experience here. And you may not want to be very as aggressive as correcting everything. And since you do not know what these packets are, I think you need to really look at how you're going to make sure that you're not creating, actually making things worse for the network, and even, sending things into congestion collapse.
Okay, thank you. I'm taking note. Any other questions?
I think we are done. Thank you.
Thank you very much.
Thank you.
Okay, so we're done. Okay, so I guess we finished early, which is always good. So thank you for coming, and I guess everybody's going home in the next few hours, few days, and have a safe trip back. And next time, for people who came from far, we're going to be the people on the East Coast of the US are going to be the one doing the long trek. So we'll see you in Singapore, hopefully not too jet lagged. Thank you.
Thank you.